Okay, so today we're going to look at graphing piecewise functions. So your learning target is I can graph piecewise functions. So there's that. I'm going to color code this graph a little bit just because I think it's a little easier for people to see. And then, so you've done piecewise functions before. You may have forgotten, so we'll review that. So let's just talk about some basic terminology. So what you have in the very beginning, you have a function, and then you have a restricted domain. So you're saying, I'm going to graph x plus 3, but I only want x's that are greater than or equal to negative 3. All right, and then the second one, you're saying, I'm going to graph 2x plus 2, but I only want x's that are less than negative 3. So when we say restricted domains, we don't mean everything can be an x. It's going to be just a certain portion of the graph. So you'll take like a piece of one graph, a piece of another graph, and you put them together and it makes a piecewise function. Okay, so the restricted domain part helps you set up the x values in your table. So what you're going to do is make a little xy table. And so because it says x is greater than or equal to negative 3, you're going to pick numbers negative 3 and then anything bigger than negative 3. So let's do negative 2, negative 1, 0, 1, 2, 3. And you can do as many as you like. Okay? So then the next part, so the restricted domain helps you get your x values. The way you get your y values is you look at the actual function, and you're going to replace the number x, or the letter x with the numbers. So if I replace a negative 3 for x, negative 3 plus 3 is 0. Negative 2 plus 3 is 1. Negative 1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. 3 plus 3 is 6. And you can keep on going forever. So just keep in mind that this does keep going. Okay. So what I'm going to do is I'm going to graph just this part, and then we'll go back and do the red in a minute. So, this first point is very important. Because it says that x can be equal to negative 3, we're going to do a closed circle at this point. So negative 3, 0, closed in. If it said that it couldn't be equal to, it would be an open circle. And then all the other points are just going to be dots that we're going to connect. So negative 2, 1, 0, 3. And once you see the graph taking form, then you just make a little line. Okay, so notice that I'm putting an arrow on this because it does continue going on forever. Alright, so that was the first part, and now we're going to do the second one. So remember, the restricted domain helps you come up with the x values in your table. So this one says that I want anything less than negative 3. Okay, but I do want to include the point negative 3 and then anything less than negative 3. So negative 4, negative 5, negative 6. You can do as many or as few as you want to. Alright, and then I'm going to use the actual function 2x plus 2, and I'm going to replace the x with numbers to get my y coordinate. So 2 times negative 3 is negative 6. Negative 6 plus 2 is negative 4. And then I would just keep replacing the x with the different numbers and getting my values. So I'm going to do that really quickly. And you can do this either with mental math or you can use a calculator. But do remember that this keeps going forever. Okay. So the very first point is always important. So notice it says x is less than negative 3. I don't want to include negative 3. So what I'm going to do is when I graph this point, I'm going to do an open circle. Because I want to know where that point is, but it doesn't actually exist right there. And then all the other points I'm just going to graph. And you just graph them until you see the actual equation or the actual graph start taking place. And that's how you do those. So they look really weird. There's certain pieces of graph put together, and that's what they do. So we use the restricted domain to come up with the x values in our table. Then we use the actual equation to come up with the y values. And then we just read the inequalities, and if we can equal the number, we close in the circle. If we don't actually equal that number, we leave the circle open. Okay, so we're going to do this one together. So notice you have 3 different equations you're looking at. So we're going to do 3 different tables. I'm going to do 3 different colors, all that good stuff. Okay, so I have 3 different colors, and I'm going to make 3 different tables. So the first one, we're going to look at this one. Remember, my restricted domain says x is less than -3. I definitely want to use -3, and then anything that's less than it. So -4, -5, -6. Alright, so notice this is not an equation. This is what your actual y-coordinate is. So whenever you have these, they're super easy. All you have to do is fill in the table. Alright, the next one. Okay, so my restricted domain tells me that I definitely want to use -3, and I want to use 4. And notice that the x is between -3 and 4, so it's saying any number between -3 and 4. So I'm just going to write all of them. Alright, and now I'm going to replace the x with the number. So -3 minus 1, -4. -2 minus 1, -3. -1 minus 1, -2. You get the picture, hopefully. Alright, and then one more. Oh, that was ugly, sorry. Here's the last one. The restricted domain says definitely going to use 4 and anything bigger than 4. 5, 6, 7. And once again, not given an equation, don't have to replace anything. That's just my y-coordinate. Okay. So the hardest part is remembering when you close in a circle and when you keep it open. So look at the very first one again. So notice we don't want x to be equal to -3 because you don't have the extra little bar on the inequality sign. So we're going to do an open circle at -3, -4. And then we're just going to graph the rest of them. And I'm going to use an arrow to denote that it still goes on forever. For the next one, these are my important points because they're listed in the restricted domain. And notice you have the equal to sign, so you do want to close in those. So I'm going to close in the circle at -3, 4. And I'm also going to do a closed circle at 4, 3. Alright, so there's that one. And then the last one, my important coordinate is 4, 3. Technically there would be an open circle here, but I've already closed it in with that second graph. So it is closed. And then I'm going to graph the other ones. And I'm going to use an arrow to denote that it goes on forever. So that's how you would do a graph like that. Once again, they're just pieces of different graphs put together. They look kind of ugly like Frankenstein at the very end. Restricted domains help you come up with the x-coordinates. Then the actual equations come up with the y-coordinates. Alright, so let's do one more together. Okay, so what I want you to do right now is I want you to pause the video and I want you to see if you can come up with the 3 different tables. So pause the video and try it, and then push play whenever you get finished or if you get stuck. So do that in 1, 2, 3. Okay, so here are the 3 tables. Hopefully you got it correct. And then we need to decide whether we have open or closed circles. So if I look at this first table, at 1, 2, notice that I don't want x to be equal to 1 because I don't have that bar. So I'm going to do an open circle at 1, 2. And then I'm just going to graph the rest of them. And I am going to use an arrow because it keeps going on forever. The next one, my important points are at -1 and 1. And since I have the little bar, that means it can be equal to. So when I graph these points, they're going to be closed. And then for the last one, here's my important point. I don't want it to be equal to -1, so I'm going to have an open circle there. And then I would just graph the rest of them. And I would use an arrow to denote that it keeps going on forever. Alright, so obviously this one is not continuous because you got some breaks and some holes, and that's fine. Sometimes that happens with Piecewise, sometimes it doesn't. It just depends on what they give you. Okay. So, if you'll go to Haiku and submit your notes, try your assignment, let me know if you have any questions. Hopefully this helped. There's extra resources because we did this in Math 3, so you can look at the video that I made for my Math 3 students and rewatch that if you need it. All right, thanks.